All right, so a lot of material in Chapter 3 and a lot of material in Lecture 3.2. I want to revisit sort of each and every key point, and this first video does that with regard to discussing what's known as the addition rule. So the addition rule treats one particular combination of two, or actually two or more events. It is it's the combination when we're interested in the probability of either A or B or both, A or B occurring. And you can see right at the top of the page the formula for the probability of A or B. It is simply the sum of the two individual probabilities with a third term which is subtracted off. And what is that third term? It's actually easy to understand. It is a correction that you make if you had double counted in calculating P of A plus P of B. And let me explain what I mean. To calculate P of A, you have to find out how many events are inside the event A, how many outcomes there are within event A, divided by the sample space, the size of the sample space of A, that's the probability. Likewise, to calculate P of B, you've got to calculate how many outcomes are within B, divided by the sample space of B. So it can be the case, it often is, that there are outcomes that are both in A and in B at the same time. And if that's the case, and you've counted them when you've counted the outcomes of A, and you've counted them when you've counted the outcomes of B, then you've double counted them. And this last term, the probability of an outcome being in both A and B, you've counted twice. And so you subtract it off one time. To talk about that again in terms of the Venn diagram on this page, again, to calculate the probability of A, you have to calculate how many outcomes are inside that circle A. Note that some are purely in A, some are in both A and B. Same is true of event B. You have to calculate how many outcomes are within that circle. Some are purely within B, some are within both A and B. So careful or not, when you count up all of the outcomes of A, add it to all of the outcomes of B, you have counted those outcomes which lie in both A and B twice, and you need to subtract it off. So let's go look at that. Let's look at two different cases. The first is called the addition rule with mutually exclusive events. So if two events, A and B, are mutually exclusive, they have no outcomes in common. Their Venn diagrams are actually pulled apart. There's no overlapping part. In that case, there is no possibility of double counting. There's nothing to double count. And as you'll see in just a minute, that term, P of A and B, is then equal to 0, right? And the addition rule then sort of collapses down a little bit. So to go through this, here's a standard deck of cards, shuffled and one card is drawn. What's the probability that the card is a queen or an ace? So let's stop there for a second. Event A is drawing a queen. Event B is we're drawing an ace. There is no overlap there, right? There are 4 queens in the deck, there are 4 aces in the deck, but there's no overlap whatsoever. There's no such thing as a queen ace or an ace queen. So if we calculate the probability of drawing a queen, 4 queens, 52 cards, the probability is 4 over 52. Calculate the probability of drawing an ace, 4 aces, 52 cards, the probability of drawing an ace is 4 out of 52. Okay, let's think about what's the probability of, on one draw, drawing both a queen and an ace. Can't do that. You can't do that. So the probability of A and B is equal to 0. And so in that case, the addition rule becomes the probability of A or B is just equal to the sum of the individual probabilities of A and B. And so P of A or B is just 4 52s plus 4 52s, 8 52s is 2 13ths. That is what happens when the events are mutually exclusive. But not all events are mutually exclusive. Those that aren't are said to be non-mutually exclusive. And here's an example. Now we're going to roll a die, 6-sided die. what's the probability that the one number that comes up is both even and less than 4? Well, let's think about that. Let's let event A be when the numbers are in the die are even. Those are 2, 4, and 6. So we just counted those 3 possibilities, 2, 4, and 6. So there's 3 possibilities in event A. There are 6 in the sample space. The probability of A is 3, 6. Here's event B. The numbers on the die are less than 4. Well, that's the numbers 1, 2, and 3. There are 3 such numbers. There are 6 total outcomes in the sample space. Probability B is also 3, 6. But now, look back. In the event A are the numbers 2, 4, and 6. In the event B are the numbers 1, 2, and 3. Notice that 2 is in both A and B. In counting 3 events in A, we've counted 2 one time. In counting another 3 events in B, we've counted 2 again. 2 is in fact the one number which is the intersection of those 2 sets. Right? If I look at the probability of P and A, right, there is actually one number in that combination P and A, it is 2, and there are 6 in the sample space. So that probability of P and A is 1/6. I have to subtract that off. So at the end, the probability of A or B is the sum of the 2 probabilities, 3, 6, and 3, 6, minus the correction, if you will, of 1/6 to give you 5, 6. So, last slide, for those of you who like to think in terms of flowcharts, if you're applying the addition rule, you are doing that because you are asked in a problem to calculate the probability of event A happening or event B happening. You will see the word "or" in the problem statement. So, are you computing A or B? If the answer is no, stop. Well, you've got to do something else. But if the answer is yes, then the next question you have to ask yourself is A and B, or are A and B mutually exclusive? If the answer is yes, they are, then the probability of A or B is just the sum of the 2 individual probabilities. If they are not mutually exclusive, then P of A or B is equal to the sum of the 2 probabilities minus that correction factor. Okay? Again, this is something you have to work out through reading problems, understanding that you're being asked to use the addition rule, and then trying to understand if the events that you're dealing with are mutually exclusive or not, and finally, calculating each individual probability. You'll get some more practice on that in the near future. All right, thanks.